Hi there, this is Mrs. Leonard. You are watching this video because you probably needed some help with the air pressure practice questions. So I'm going to go through a bunch of these different practice questions for you. We're going to look at how to convert air pressure. We're going to look at station models, and we're also going to look at some of those high pressure and low pressure air systems. So you can skip around in this video so that way you don't have to watch the whole thing. Just skip to the parts that you need help with and then go back to your practice questions on the Google form. And if this video is still not helping you, feel free to invite me to a Google Hangout. Ms. Zoll put directions up on her Google Classroom for that if you're not sure how to do it. I'm available every weekday, Monday through Friday from 2 to 3:45 p.m. All right, the first one we're going to try practicing is converting pressures to the other units. So right here you can see we're going to convert millibars into inches of mercury, and you need to use your reference tables for this. This is on page 13. If you don't have your reference tables with you, which you probably don't, then there is a link on the first page of the Google Classroom. Click on that link, and all you need to do is print out the pages that you need, or if you can't print them out, then have them up on your phone or someplace so that way you can use those. So this is just like what we did in class with the temperature scale, exactly the same thing. It's just that now we're using the pressure scale. So millibars is on the left-hand side. Here you can see, and that word bar, anytime I see the prefix or a suffix with bar, that just means pressure. So this is kind of like millimeters, but it's millibars. And then inches over here on the right, this is United States units. We're pretty much the only ones in the world that use these. Almost everybody else uses the millibars. So we're going to convert 1013.2 millibars into inches. So first we have to find 1013.2. And there's 1012, there's 1016, so 1013, each of these are going up by 1, so this is 12, 13, 14, 15, 16. So that means that 1013 is right here, and 1013.2 is right where that dotted line is. That's also called 1 atmosphere of pressure. So when I follow that straight across, that is on this little line here, if this is 29.90 and this is 30.0, then halfway would be 29.95. That would be this line right here. And so that means that each of these are going up by 0.01. If you get confused about decimals, think about this in terms of money. This is like going up by a penny, 1 cent, right? And so if this is 29.90, this would be 29.91, 29.92. So that would be our answer for that one. For the next one, you do the same thing. This time we're looking for 1022.8. 1020 is right here. 1024 is here. So this would be 21, 22. 1022.8 is going to be a little closer to 1023, I should say, which is right here. So maybe right about here. And if I follow that straight across, it lines up perfectly with this line right here, which is 30.20. So that's our answer here for this one, 30.20. All right, and now we're going to go backwards. This time we're starting with 30.53 inches over here. So 30.50 is right here. This is 30.60. So 30.50, and remember we're going up by a penny, 0.01. So if this is 30.50, this is 51, 52, 53. And if I follow that straight across, lines up perfectly with this line right here. So we have to figure out what that line is. If this is 1032.0, and I'm looking for this one, this is 1036. So 1032, 33, 34, 35, 36. So this line right here, the one I was looking for, is going to be 1034. So I'm going to write that right here, 1034. Oops, 0.0. Okay. And then the last one. This is 29.81. Down here, this is 29.80. So 29.81 is the line right above that. And if I follow that straight across, it kind of looks like it's halfway between this line here and this line here. And if this is 1008, this is 1009, 1010. So it's probably halfway between, which would be 1009.5, just like that. Okay. So hopefully that helps you out with the converting of the pressures. Let's take a look now at station models. Before we do that, if you want to scroll ahead in this video, there are some practice questions with pressure at the end, so you can kind of test your understanding and see if you really understand that. So feel free to kind of scroll through to some of those questions to make sure that you really understand it before you go back to your Google form. Okay, so we've looked at these station models before. If you remember, when we were talking about temperature, temperature was always this number here in the upper left-hand corner of this little circle part of our station model. So now we're just adding to that. We're now going to look at pressure. So pressure is always in the upper right-hand corner. So this number right here is the pressure number. And if I come over here, it tells me that 196 is the barometric pressure. And it tells me in parentheses what this little code number stands for. So this little code number 196, which is what's on our station model over here, that code is really a barometric pressure of 1019.6 millibars. So when you see that code, you have to know, okay, I either am going to add a 9 in front or a 10 in front of this number. So how do you know which one you add? Well, if this first number is lower than 5, like this one right here is a 1, so if it's lower than 5, you add a 10. And the way I remember that is if it is any number between 0 and 4. Okay. If that first number is greater than 4, in other words, if it is 5, 6, 7, 8, or 9, then I'm going to add a 9 in front of it. Okay. So let's do an example. Up here, we have a station model. Okay. And this station model has a pressure of 997 for the code, right? That very first number there begins with a 9. So since that number is a 9, when I come down here, it's between 5 and 9. And so I'm going to add another 9 in front of this number right here. So when I write that out, that would be 9, 9. You know what, I always have to I put the 9 in front of it when it's actually on the paper. And then that way I don't forget how many nines, because this is confusing, right? There's a lot of 9s there, 999. And then you always put a decimal point in between the last two numbers. So it's going to be 999.7, and then you put the units, millibars. And that's it, okay? So this one over here on the right here, do the same thing. It's just that now this number starts with a 0. And since it starts with a 0, I'm not going to add a 9, I'm going to add a 10 in front. So I'm going to erase what I just put there. Okay, so I'm going to put a 10 in front of this and a decimal here so that my actual air pressure is going to be 1002.4 millibars. And I really strongly recommend that you write it on the paper first. Can't tell you how many students will convert that and they'll say, oh, it's 1024.0, and that's wrong. So I really strongly recommend that you put the numbers on there, the 10 or the 9, and add your little decimal point. If you do that, you won't get it wrong. Okay, the other thing that you need to know how to do is this pressure trend. The pressure trend tells you what the pressure's been doing. So in other words, if the pressure's been going up, this will tell you that. If the pressure's been going down, this will tell you that, okay? So on our station model, the pressure trend is right here, and it tells you that over here in the explanation, right? So the +19 is the barometric or the pressure trend, and that just means that it's been rising 1.9 millibars in the past 3 hours. It's always going to be in the past 3 hours, okay, whatever this trend is. The plus tells you it's rising. If this were a minus, then that would tell you that it is falling, okay? And the pressure trend is really helpful because if the pressure is falling, that probably means that we're going to have a low pressure system coming in, right? Low pressure, the pressure is falling, it's getting lower. And if it's getting lower, it's probably going to rain. Low pressure systems always bring with them rainy weather. And if the pressure is rising, like on this one, then that probably means a high pressure system's coming in. And so we're going to have nicer weather. It's going to be clear skies and sunny and really nice weather. So this pressure trend is actually a really great way for meteorologists to be able to predict the weather, right? This is just one of those tools that they use to help them out. And then the other thing that you should know is that they're never going to put a decimal point in between these two numbers on the actual station model, but there is a decimal point in between those two numbers. You're never going to see a pressure trend. You're never going to see the pressure rise 19 millibars. That's just insane. That's like, you're like on another planet if that happens. Okay? So there's always a decimal point in between those two numbers. All right. So let's practice this. In this question right here, it says the air pressure is 1023.2 millibars and has dropped 1.2 millibars over the past 3 hours. Go ahead and see if you can figure out what codes you will put on this station model right now, and go ahead and type in your answers, and then you can see if you're right afterwards. Okay, so hopefully you got that right. You should have said for this pressure, this goes up here in the upper right hand corner, and I'm only going to take the last 3 digits because that's what goes on the station model. So you should have something that looks like that, 232. And then the pressure trend, it is dropped, so that means I would put a minus, and it's 1.2 millibars, so I'm just going to put a 1 and a 2, no decimal point, because if you look down here, there's no decimal point on the actual station model, which is what we're drawing up here. Okay, here's another one to try. The diagram shows a weather station. The barometric pressure is A, 10.28, B, 1013.0, C, 913.0, or D, 130.0 millibars. All right, hopefully you got that right. So you're looking at this code right here. And if you remember, that first number tells you what number to add in front of it. Since it's less than 5, I am going to put a 10 in front, and then I'm going to put a decimal in between the last two numbers. So it should be 1013.0 millibars. So answer B was correct. And now you can try the barometric trend. So what is the barometric trend for this weather station? And hopefully you got that one right. So you're looking at this number right here because it's the one underneath the barometric pressure. And if you remember, all you have to do is put a decimal point in between those two numbers. So I know it can't be A or B because those numbers don't have the decimal point between it. C and D, they do. And since this is a minus sign, I know that it's falling and not rising. So it can't be C. The answer has got to be D. All right, here's another one. Again, if you don't need this practice, then feel free to go to your practice worksheet on the Google form. But if you feel like you need some more practice, you can keep on trying some of these. So it says a weather station records a barometric pressure of 1013.2 millibars. Which diagram below would best represent this weather station on a weather map? So notice that they only have 3 digits for each of these. And if you remember, we're using whenever we have to convert them, we always have to add this 10. So that means that we have to remove that 10 when we are converting it into the code number for the station model. And then we just remove that decimal point. So the correct answer should be 132, which is not that one, not that one, not that one. So it's definitely B. All right, so this weather station records the following data. Air pressure is 1001.0 millibars and has risen steadily 1.1 millibars over the past 3 hours. Using the proper weather map symbols, place this information in the correct locations on the weather station model provided. All right, so you should have looked at the air pressure. The air pressure should go up here. I have to get rid of this 10, get rid of the decimal, get rid of the units. So that means it's 010 up here in the upper right-hand corner. And this is talking about the pressure trend. It's what's happening to the pressure over the past 3 hours. And it has risen, so that means I'm going to use a plus. And it's risen 1.1 millibars, but I don't use the units and I don't use that decimal, so I'm just going to say plus 11. Okay, so this is a practice question converting those air pressures. So if you don't need this practice, again, you can skip to the end. I have a question about high and low pressure systems if you want to skip to that. Or if you are all set, then go ahead and go to those the Google form practice questions and you can start on those. So this question says, an air pressure of 1005 millibars is equivalent or equal to how many inches of mercury? So 1005 millibars, if I come over here, this left-hand side is my millibar side. Here's 1000, 1004, 1008. So if this is 1004, right here is 1005, 6, 7. Yep, so that's 1005 right here. Following that straight over, looks like it is above this line, which is, this is 29.6, 29.7. So halfway right there is going to be 29.65. That's this line here. But what I'm looking for right now is 29 point, let's see, this is 1005. So that's going to be 29.65, 0.6667. So something like maybe 67 or 68. So 29.68 is what I'm looking for. It's not 58. 0.72 is too high. Oh, it's right there. 29.68. All right, same kind of question, but this time we're kind of going the opposite way. Because now, according to the reference tables, an air pressure of 29.65 inches of mercury is equal to how many millibars? So I have to find 29.65, 29.6, 29.7. So 29.65 is right here. Follow that straight over, and it's very close to 1004. And when I come over here, yep, there it is. So the correct answer should have been A, 1004. All right, the last thing that students tend to have a hard time with is the difference between these high pressure systems and low pressure systems. We know, or you should know, that whenever the pressure systems are high, that they are going clockwise, right, and out of the center. The reason that the air flows out of the center of a high pressure system is because the air is going from high pressure to a low pressure system. So it goes out of the high and into the low. And that just kind of makes sense. If you had a balloon and it was full of air and there was lots of pressure, the air was like pushing out on that balloon to keep the balloon inflated. As soon as you puncture a hole in that balloon, all of the air from that high pressure system inside the balloon is going to go out to the air outside, which is a lower pressure. So that just is kind of how I think of it, okay? Now, the clockwise versus counterclockwise thing is a little bit harder to remember. If we were in our classroom, I would walk over to the door where we have a counter. And if you remember, we have like our cute little drawers with our period 1 and 2 and period 5 and 8 over here, right? You know what I'm talking about. And right above that, there's like a nice little clock which none of us ever use because now we use the digital one in the front of the room, but that's okay. So here's our clock, right? And then this is our counter. But what I've always told students, and it's always helped them to remember this high pressure and low pressure systems, is that the counter is low and the clock is high up on the wall, right? So sometimes I'll even go over and I'll slap the counter. I'll be like, this counter is lower than the clock. The clock is way up here, higher on the wall. So I always remember high pressure systems go clockwise and low pressure systems go counterclockwise. Now, if you don't know what clockwise and counterclockwise, it's just the way a clock goes. So clockwise just means, oh, 1, 2, 3, right? So this is clockwise, going around the clock clockwise, versus counterclockwise, which is just going counter to that. It's just going the opposite direction, counterclockwise, okay? So when I get these questions, the first thing I think about is whether or not the air is going into or out of. Because I know for high pressure systems, it's going out away from the high and it's going toward the low pressure system. So that's the first thing that I look at. In A, this is going out, and for the high pressure, and for the low pressure, it's going in. So I know that's a possibility. For B, it's going into the high pressure system and out of the low. I know that that can't be it, so I can cross that one out. For C, it's going out of the high and out of the low, so I know that can't be a possible answer. For D, it's going into the high and into the low, so I know that that can't be a possible answer either. So I really, for this particular one, I didn't even have to know the clockwise and the counterclockwise one, but for some of them, you do have to know that. All right, hopefully that helped. If it didn't, again, go ahead and invite me to Google Hangout between 2 and 3:45 any day, Monday through Friday, and I will try to help you out with that. Good luck.